Hello, thank you for the chance to discuss statistics and exploratory data analysis. I will give a compact overview of the key concepts I use when approaching new data, how I reason about them, and concrete examples that demonstrate practical use. Here, I want to start by a problem statement and goal. When you get a data set, the first aim is to understand its shape, quality, and any patterns that will affect modeling decisions. EDA means asking, what does the center look like? How spread out are values? Are these anomalies? And how do variables relate? Descriptive statistics are the foundation. I summarize variables with mean, median, and mode to capture central tendency. I always state why I choose one over the other. The mean is efficient but sensitive to outliers. The median is robust for skewed distribution. Mode is useful for categorical features. I look at spread using standard deviation and variance. And for distribution shape, I compute skewness to detect asymmetry and kurtosis, kurtosis to access tail weight. Practically, I compute quartiles and interquartile range IQR because it feeds into a robust outlier detection rule. Anything above quarter 1 minus 1.5 into IQR or above quarter 3 plus I 1.5 into IQR is suspect. Probability distribution. I check whether a numeric feature resembles a normal distribution or something else. Uniform, exponential, binomial for counts. Visual checks are important. Overlaying a normal curve on a histogram or using a QQ plot quickly shows deviation. These shape assessments guide transformation. For example, using a log or box score transforms when the distribution is right skewed before applying linear models. Hypothesis testing helps answer specific questions. For example, if I am testing whether a sample mean differs from a hypothesized value, I use a one sample t test to compare two groups. I use a two sample t test or Wells t test if a variance differ. For categorical relationships, I use a chi-square test for independence. With all tests, I report the test static p-value and a practical interpretation. P-value below alpha, commonly 0.05, signals evidence against the null. But I always always complement this with effect, size, and domain context. Significance is not the same as practical importance. Correlation and covariance are next. Covariance tells me whether futures move together but is scale dependent. Correlation standardizes this to the -1 to 1 range, making it Easy to compare relationships. I compute a correlation matrix and visualize it with a heat map to spot strong pairwise relationships and potential multi-core linearity. For continuous variables, I will use person Pearson correlation. For ordinal or non-normal data, Spearman's rank correlation is more robust. Putting it all together, an EDA workflow, inspecting data types and missingness, generate descriptive statistics and look at distributions, visualize using histograms, box plot, scatter plot, and pair plot, detect outliers using IQR and Z-score methods, investigate whether they are errors, rare events, or important signals, check correlation, check correlations and multi-collinearity, run normality tests whether assumptions matter for parametric test or models, apply transformations or encodings as needed and recheck. Concrete examples I would speak to in sample dataset I created. Income showed right skewed. Income showed right skewed and several high values outliers. I used the IQR rule and also Z-score threshold, where Z-score greater than 3 to identify outliers. Visualized them on a box plot and scatter plot and then decided based on domain context whether to cap, transform or leave them. For relationships, plotting age versus income and credit score versus income with a correlation heat map quickly highlighted with futures should be combined or dropped due to multi-core linearity. For normality and modal assumption, I use both visual diagnostics, histogram plus normal curve, QQ plot, and a formal test like diagnostic K2 and Skypyro. While I explain that large sample tests can show significant for departure from normality even when deviations are small. So I balance test results with plots and intended model's robustness. EDA EDA is iterative and communicates hypotheses back to stakeholders and informs future engineering. Emphasize reproducibility, scripts and notebooks that log steps and reasoning, and that every EDA decision should be justified by evidence and business context.